All right, let's dive into a really fascinating cosmic puzzle. Our best, most trusted laws of physics practically scream that a certain kind of star has to exist. But here's the catch. Even though science calls it a physical inevitability, we've never actually confirmed we found one. We're talking about quark stars, and today we're going on the hunt.
And that's really the core of it, isn't it? It's a huge paradox. If the standard model of particle physics and Einstein's general relativity are as correct as we think they are, then quark stars should be out there. So, where are they? It's a question that honestly challenges our whole picture of the universe, and, it pushes us right to the edge of a major discovery. So to really get why scientists are so sure about these things, we've got to look at the very foundations of modern physics. This isn't some sci-fi idea that requires inventing new particles or extra dimensions. No, this is about taking the physics we already know and just following the logic all the way to its wild, incredible conclusion.
Now this is what makes quark stars so different and, frankly, so compelling. You see, a lot of other exotic star ideas need us to invent new physics to make them work. But quark stars, they pop right out of the physics we already have, the standard model and general relativity. They're not a what if, they're a what should be.
So you see, the very existence of quark stars is a massive test for our most fundamental theories. If they aren't out there somewhere, then something in our understanding of the universe is, well, seriously off. So if they really are inevitable, what in the world are they?
To understand what a quark star is, we have to go somewhere extreme. We're talking about a place where the laws of nature are stretched to their absolute breaking point. And this whole story, it all begins with the spectacular death of a truly massive star.
I want you to just imagine this for a second. A star so incredibly dense that its gravity doesn't just crush atoms, it completely obliterates them. And then it keeps crushing. It squeezes the neutrons themselves so hard they just dissolve into a sea of their basic parts, quarks. That's a quark star, a celestial body made of the most fundamental building blocks of matter we know.
Okay, so the journey starts with a supernova. The huge core left behind collapses into a neutron star. Now this neutron star is in a constant battle. Gravity is trying to crush it into nothing, but a quantum force called neutron degeneracy pressure is pushing back. It's basically the neutrons saying, hey, we refuse to be squeezed any closer together. But if the original star was massive enough, gravity ultimately wins that fight. The neutrons are broken, and the star is reborn as this quark soup.
Just to try and wrap your head around that density, imagine taking the entire human race, every single person, and squishing us all down into the size of a sugar cube. That's the kind of mind-boggling environment we're talking about. A quark star is even smaller and denser than a neutron star. It's the true heavyweight champion of the cosmos, right before you get to a black hole.
So, if these things are really out there, how in the world do we find them? Well, it's like a cosmic detective story, really. And scientists have a checklist of clues they're looking for. The telltale signs, the smoking guns, that would prove an object is a quark star. So what's on this cosmic checklist? First, is the object too small to be a neutron star? Second, is it too massive? Does it have a bare quark surface that glows with a really specific kind of X-ray signature? And finally, maybe, did it create something called a quark nova, a sort of second, smaller explosion when it was first born?
Of all those clues, the one that really matters most is the radius, the size. Our models are pretty firm on this. If we find a compact star that's smaller than about 11 kilometers across, it just can't be a neutron star. That would be it, the definitive proof, the smoking gun that solves the whole mystery.
And believe me, the search for that smoking gun isn't just theory. This is a real-world, honest-to-goodness scientific quest. Right now, as we speak, we have a whole fleet of incredibly powerful instruments out there on the front lines.
Our toolkit for this is pretty impressive. We've got NICER, which is attached to the International Space Station, using X-rays to measure star sizes with insane precision. We've got LIGO and Virgo listening for gravitational waves from colliding stars. The exact signal they detect can tell us if the cores were solid or kind of squishy, like a quark soup. And we have even more powerful tools on the way, with missions like EXTP and Athena coming down the line.
We are absolutely entering a golden age for this search. With every single new observation from the instruments we have right now, we're inching closer to an answer. And as you can see, the next couple of decades are packed with potential. This could very well be the era where we finally solve this cosmic mystery. So, why is this search so incredibly important? Well, it's not just about finding a new flavor of star. It's about opening a brand new window into the fundamental laws of nature itself.
You can think of quark stars as natural particle accelerators, but way more powerful than anything we could ever hope to build here. They let us study the strong nuclear force, the theory called quantum chromodynamics, or QCD, that glues quarks together, in a way that's just impossible in a lab. It'd be like getting a ringside seat to the most extreme physics in the entire universe.
Discovering a quark star would be a true landmark moment in science. I mean, it would add a completely new, confirmed member to our cosmic family. It would change our understanding of the universe forever. And yes, it would literally mean rewriting the textbooks for the next generation of astronomers.
And this quote really captures the excitement perfectly. Finding the first quark star would be a genuine revolution. We're talking about a Nobel Prize-winning achievement, something that would completely transform how we understand matter at its most basic level.
So the hunt for quark stars goes on. And it's a great reminder that the universe is just packed with wonders we haven't even dreamed of yet. If something as strange and as extreme as a quark star is a physical inevitability, it just makes you wonder what other incredible things are out there, hiding just beyond what we can see today. The search continues, and the next amazing discovery could be right around the corner.